So in today's video, we're going to look at the different ways that you can do loops. So a loop is a way to go through and replicate or repeat a pattern for multiple times. So this can be, you may loop through a number of rows until you get to the end. You can loop through columns till you get to the end of the columns. You can loop through a number until you get to a certain number. You can also do different loops, like you can loop through collections, you can loop through the sheets on a workbook, you can loop through files in a folder. There's all sorts of scenarios for using loops. But what we're going to go through right now is just doing a simple loop just with a number and looping from, in this example, we're going from 1 to 100. And we're just going to show you the different ways to do this and why you may or may want to do one way versus another. A lot of this, I will tell you, is probably preference. We'll talk about performance in a minute. I'll show you what I do, what my preferred method is, but for each individual, it's up to you. So the first method is for, and this is essentially saying that you're going to set a value. I've got this set to int4. I've got these set to doubles, as we're going to look at larger numbers in a second, but int4 equals 1 to 100. So essentially it's going to say just keep increasing int4 to get to 100. And then once you reach 100, exit. So this is coming after. So if you wanted this to go till it was bigger than 100, then you would have to do 101, if that makes sense. So this will simply loop through. So if I just run this, you can see it loop through each one until it got to until it got to 100, and then it exited. The next one is do. So this is going to say I'm going to start at 1, so I'm going to set the value as 1. I'm going to increase it by 1 each time. I'm going to call that out explicitly, and I'm going to keep doing that until int do is greater than loop 2. You can do greater than or equal to. So let's do greater than equal to. So if I loop through that, that should take me all the way down to 99, because once it reached 100, because I had the equals here, it exited that at 99. If I left that as greater than 100 and rerun that, you can see that now goes to 100. So for all of these, it's important to understand that last number and whether that's going to be included or excluded in your value. This is also exiting at the end. So this is exiting at the beginning, and this is exiting at the end. The next one is while. So this is saying while this value is less than this value, just keep going and then just increase it by 1. So if we loop through this, this again is going to get to 100 because this should be greater than or equal to. So if I change that from greater than or equal to, and I loop through, it takes you to 100. And the next one is do while, which is sort of similar to the one above. This is just going to go through. This has the while end, which is when, and this one just has the loop. And then this is going to go through again. I did less than 100. So if I change that to less than or equal 100, it will go all the way to 100. So very important that you understand when this is exiting and what number it's using and whether it's greater than or equals to. I always run a test to make sure that last number is included or not. Even when you're looping through rows, you want to make sure that you're including that last row. You don't just get to the last row and then exit. Similarly, you don't get to the last row, go to the next row and try and process like a blank row. So it's important for your code to understand that and for your loops to exit correctly. So now we're going to look at performance. So here I'm going to do something similar. What I've done is I removed the writing of that value to the cells because we're going to be going much larger than the sheet can hold. I also am going to remove do events. Do events does slow down your code. However, again, if you're running a small loop and you want to have do events excluded, it will run faster. But one of the things with loops that do run for a long time is people get nervous when it says like not responding, and they'll bomb out of your sheet or your workbook when really it's just running in the background. So that's why I have do events. But we're going to remove that for this because these numbers are so large. And then I'm going to record each of these as they go through. So let me go ahead and kick this off. All right, so this is finally completed. You can see here the values that are coming back. So I've got for the 4, I've got that at 35 seconds. Now, one thing I did was I actually moved this forward to the end of my code to make sure that it wasn't something with having more memory at the beginning of the module or the beginning of the sub and then running out of memory. You can see like these get increasingly larger as you go up. It just happened to be that way. And like I said, I did move to the 4 to the ends just to make sure. But so for this, again, this is just looping through numbers. This isn't actually doing any activity. It isn't actually doing anything. So this is truly the performance of these loops. The for loop took 35 seconds. The do loop took 144. The while loop took 149. And the do while took 155. Now, again, this is to go to 9 billion. So this is a very large number. This is a very high number of loops to go through. But there is a slight performance. Now, if I was to change this and go to 90,000, let's take that to 90,000, and I was to run this again, it's nothing. These to go to 90,000 takes less than a second for each of these. Even if we increase that to 900,000, it still takes less than a second. You really have to really increase this by huge numbers in order for this to run and have any significant kind of delay. So, and that was 9 million. So if I keep increasing this, we'll get back to the 9 billion with a significant difference in each of them. But for most of these smaller numbers, which includes running up to, 9 million, they are still only taking a couple seconds. So, sorry, 90 million. So 90 million is for the for, it's pretty much instant. And then the do, the while, and the do while are 1 second, 2 second, 2 second, respectively. So still very, very fast for 90 million loops. Thank you for watching. Please don't forget to like, subscribe, and comment. Please also share. Please go ahead and check all my other videos on my page. Have a great day.